Your assistant just handed you a quote, a source, and a page number, and every one of them is invented, delivered with the exact same calm confidence as the true things it told you a second earlier. It didn't glitch, it didn't warn you. It did precisely what it was built to do. And here's the part that should stop you cold. In April of 2025, the newest, smartest reasoning models did this more often than the ones before them. And the company that built them admitted it couldn't fully explain why. Researchers have a name for this. They call it hallucination, when a model states something invented with the same confidence it uses for a fact. And it's a deeper, more useful question than the one everyone already knows the answer to. Not AI makes mistakes. The real question for anyone doing actual work is this: why does a system that can draft a flawless legal brief confidently cite a court case that never happened? And why didn't simply making the models bigger and smarter make that problem go away? The answer isn't a bug someone forgot to patch. It's baked into how these systems work at the most basic level. And once you see it, you'll never trust an AI answer the same way again, which, it turns out, is exactly the right way to trust it. Let's start with what's actually happening when a model writes you a sentence. A large language model does one thing, over and over, faster than you can blink. It predicts the next word. You give it some text, and it asks, given everything before this, what word most likely comes next? Then it picks one, adds it, and asks again. That's it. That's the whole engine. Everything these systems do, writing code, drafting emails, explaining tax law, is that single trick repeated thousands of times. Now, sit with what that means. Nowhere in that process is there a step that checks the world. There's no moment where the model pauses, looks up a fact in some internal library of truth, and confirms it before speaking. It has no such library. What it has is a vast, compressed sense of which words tend to follow which other words, learned from oceans of text. When you ask who won a specific award in a specific year, it isn't retrieving a record. It's generating the most plausible sounding continuation. If the true answer was common in its training data, the plausible continuation and the true answer are the same thing, and you get a correct reply. But if the true answer was rare, mentioned once or never, the model still produces something. It produces the shape of an answer, a name that sounds right, a citation formatted perfectly, a page number that fits. This is the crucial idea. The model isn't lying, because lying requires knowing the truth and choosing to hide it. The model doesn't know the difference. To the machine, a true fact and a fluent invention are produced by the identical process. They feel the same from the inside because there is no inside that separates them. There's a paper from OpenAI and Georgia Tech published in September 2025 that puts hard math under this. It points out that if a certain kind of fact, say a person's birthday, appears exactly once in the training data, the model is likely to hallucinate on those facts. Seeing something once simply isn't enough to reliably reproduce it. Their example: if 20% of some category of facts appeared only once in the training data, you should expect the model to get at least 20% of them wrong. That's not a flaw in one company's model. That's a statistical floor built into learning language from examples. So that explains where hallucination is born, but it doesn't explain why it survives. Because here's the reasonable objection. Fine, the model doesn't know some obscure fact, so why doesn't it just say, I don't know? You'd say that. Any honest expert would. Why won't the machine? This is where the story gets genuinely uncomfortable, and where the second half of the mechanism lives. The reason models don't say, I don't know, is that we train them not to. Not on purpose, but through the way we grade them. Think about how these systems are evaluated. They're run through enormous batteries of test questions and scored on how many they get right. Now picture you're taking a multiple choice exam where wrong answers and blank answers both earn 0, but a lucky guess might earn a point. What's the optimal strategy? Never leave anything blank. Always guess. Confidence is free. Abstaining is pure loss. The same paper says it plainly. Under these scoring regimes, an honest "I don't know" is maximally penalized, while a confident best guess is the optimal move. We built a testing environment that rewards bluffing, and then we're surprised our models bluff. We didn't train them to be truthful. We trained them to be good test takers. And a good test taker, faced with a question it can't answer, does not raise its hand and admit ignorance. It writes down its most plausible guess in its neatest handwriting and moves on. That neat handwriting is the confident tone you hear. The polish isn't evidence the model knows. The polish is the whole problem, because it looks identical whether the answer is solid or fabricated. So we have two forces. First, a prediction engine with no ground truth check, which means invention is always possible. Second, a training and scoring culture that rewards confident guesses over honest uncertainty, which means invention is actively encouraged. Put those together, and hallucination isn't an accident. It's the predictable output of the system as designed. Now, the obvious hope. If the problem is the models aren't smart enough to know when they're guessing, then surely the next generation, bigger and more capable, fixes it. That's the intuition almost everyone has. And in April 2025, reality did something startling with that intuition. OpenAI published a system card, the technical report a lab releases describing how a new model behaves for two new reasoning models, O3 and O4 Mini, their most advanced at the time. And on their own internal test of factual accuracy about people, the numbers went the wrong direction. Their older model, O1, hallucinated about 16% of the time on that benchmark, a benchmark being a standardized test researchers use to score accuracy. The smarter new O3, 33%, double, and O4 Mini, 48%, nearly half. On a broader factual test, the pattern held. Independent researchers found O3 doing something almost eerie, fabricating accounts of actions it claimed to have taken, insisting it had run code on a laptop it never had access to. And in the official documentation, OpenAI's own words were that more research is needed to understand why. Let that register. The people who built the smartest models on Earth watched them get less truthful and said, in effect, "We're not entirely sure why." Now, this is exactly the moment to slow down, because it's also the moment where it's easy to draw the wrong lesson. The tempting headline is, "Bigger models hallucinate more. It's a law of nature. The technology is doomed to get worse." That is not what happened. And if you repeat it, you'll be wrong within the year. Here's the honest reading. Part of that spike is that the newer models simply make more claims overall. They attempt more, so they're wrong more in absolute terms, alongside being right more. Part of it is that O4 Mini is a deliberately small model, and small models know fewer facts, so some of that 48% is a size effect, not a reasoning effect. And most importantly, the very next generation reversed it. When GPT-5 arrived later in 2025, hallucinations dropped sharply, especially when the model was allowed to reason carefully and connect to the live web. On one factual benchmark, its error rate fell from around 47% to under 10%, once it could ground its answers in real sources. So the real lesson of 2025 isn't smarter is worse. It's stranger than that. Capability and truthfulness are not the same axis. You can make a model dramatically smarter and watch it get less honest. Then make it smarter still and watch it get more honest. Because the thing that actually moves truthfulness isn't intelligence. It's two other things. One, whether the model is grounded in real sources when it answers. Two, how it was trained and scored along the way. Capability alone doesn't fix hallucination. It doesn't doom you to it either. Grounding and training do the real work. Which brings us to the only part of this that changes your Tuesday. You're not going to retrain these models, but you absolutely can control the two conditions that decide whether you get burned. First, know exactly where hallucination spikes so you can raise your guard at the right moments. It spikes on obscure, long-tail facts, the thing only a few sources ever mentioned. It spikes on specific numbers, dates, and quotes. And it spikes, worst of all, on citations. Across studies of more than a dozen models, fabricated or inaccurate citation rates ranged from a modest fraction to the overwhelming majority. When an AI gives you a source, a case name, a study, a page, that is the single least trustworthy thing it produces, precisely because a citation is easy to format plausibly and hard to generate truthfully. The confident footnote is where you should be most suspicious, not least. Second, the one habit that fixes most of this, ground it, then verify it. Grounding means don't let the model answer from memory when it doesn't have to. Give it the actual document. Point it at the real web page. Connect it to your real files. This is the biggest single lever that exists. It's what took that error rate from nearly half down to under 10%. A model reasoning over a source you handed it is playing a completely different game than a model free associating from training data. But grounding has a limit you need to hold in your head because it's where overconfidence sneaks back in. Grounding fixes factuality, whether the underlying fact is real. It does not fully fix faithfulness, whether the model read that real source correctly. A grounded model can still misquote a document that's sitting right in front of it. So grounding is the first move, not the last one. For anything you genuinely cannot afford to get wrong, a human still checks the source. Here's the operator's rule, and it's the whole episode in one line. Assume the model is a confident guesser. The moment it gives you a name, a number, a date, or a citation you can't afford to be wrong about, make it show its source and check it. And this is where the field actually converges, which matters if you're choosing tools. Whether you're leaning on ChatGPT, on Claude, on Gemini, or on Microsoft Copilot inside your own environment, none of them is immune, because none of them escapes the prediction engine we started with. But the direction they're all racing is the same, and it's the right one. ChatGPT, Claude, Gemini, and Copilot are all working to connect the model to real, verifiable sources and show you where the answer came from. References you can click. That visible sourcing isn't a marketing feature. It's the actual mechanism that turns a confident guesser into something you can audit. So the verdict isn't trust this brand over that one. The verdict is trust grounded and cited over ungrounded and fluent every single time, regardless of whose logo is on it. The polish is not the proof. The source is the proof. So here's where we land with no hedging because you came for an answer. Hallucination is not a passing flaw that the next big model will quietly erase. It's a structural feature of how these systems predict language, kept alive by how we grade them. But it is completely manageable. Not by waiting for smarter AI, but by grounding your questions in real sources and verifying anything that matters. Capability alone won't save you. Your habits will. Next in this arc, how ChatGPT, Claude, and Copilot actually read your company's files. We open up grounding itself, the single biggest lever for turning a confident guesser into a source you can check, and the reason a model connected to your own documents behaves so differently from one running on memory alone. If today was about why AI invents things, next time is about how we get it to stop. I'll see you under the hood.